Good evening, everyone, and this is lecture number 6. And we are dealing with Young's double slit experiment. In the last class, we had seen different terms. We had seen where will you have dark fringes and where you will have bright fringes, constructive interference and destructive interference. For bright fringes, we have for for bright fringes we have this y is n times d lambda by d. Do we remember this? Yes or no?
Yes, sir.
And for your dark fringes, it is 2m minus 1 lambda by 2 into d by small d by capital D. We had seen what we understand by fringe width. Yes or no?
Yes, sir.
We understand what do you mean by a fringe width. Fringe width is the distance between any two consecutive dark or any two consecutive bright fringes. Yes or no?
Yes, sir.
And we had found out
Yes,
the value of that fringe width, that was equal to d capital D lambda by small d. We had also seen the angular fringe width, and the formula for angular fringe width is lambda by small d or beta by capital D. Everyone understands this? Yes or no?
Yes, sir.
Okay, we're almost done with everything here, and we'll just write down the important points that are going to help you. And all these important points are not important points, they are actually questions that are going to come in your exam. So let us start with this. Some important points about fringes and fringe width and everything. Important points about fringe and fringe width and everything. What is the first point? What is the first point that you must understand? The first point that you must understand is okay, I just need to do that. Okay, the first point that I need to understand is number 1, all fringes are of equal width. All fringes are of equal width. So whether you talk about the central fringe, you talk about the dark fringes, bright fringes, all the fringes are of equal width. And what is the fringe width? It is always equal to lambda d by small d. And the angular fringe width alpha is lambda by small d. Or you can write it as beta divided by capital D. I hope everyone understands this. Yes or no?
Yes, sir.
Okay, all fringes are of equal width. This is a very important aspect because in the next topic, something is going to change. Second thing, if YDSE is done in another medium, not air, but it is done in some other medium. Now what will happen if it is done in some other medium? Your lambda in the medium will change, and that will become lambda in air divided by mu of the medium, because lambda keeps on changing. Yes or no? And you know
Yes,
that
sir.
fringe width is directly proportional to lambda. So because of this, the fringe width in the medium will become lambda in the medium. Oh, sorry. Lambda. Why I'm writing lambda? The fringe within the medium will become beta divided by mu of the medium. Do we understand this?
Yes, sir.
For example, if I conduct this experiment in water, We all know what is the mu of water. Refractive index of water is 4/3. Yes or no? Refractive index of water is 4/3. Yes or no? Do we remember this?
Yes, sir.
So the mu, the lambda in water will become lambda divided by mu, and fringe width in water will become fringe width in air divided by mu. Mu is 4/3, so it will become 4/3 of beta in air. Do we understand this?
Yes, sir.
Every point that we are writing are potential questions. Okay, I hope everyone is noting them down. Yes or no? We
Yes,
move
sir.
on to the third point, and the third point is this. This beta is inversely proportional to 1 by d. That means if you decrease the separation between the two slits, beta increases. If you increase the separation, beta decreases. Do you understand this?
Yes, sir.
Then we have position of nth bright fringe. Now, this is just a repetition of what we had done, but we will again write it in a different way, and the different way in which we write matters. You know why n was given as n times lambda d by small d. Yes or no? Now I can write this in this fashion. Nth bright fringe will be n multiplied by beta, because beta is equal to this. Beta is equal to lambda d by d. I hope you understand this. Yes or no? I'll give you time while I'm finished with all the points. I will give you time. Don't worry. This is the position of nth bright fringe. Now, if I go on the same point and I ask you what is the position of mth, I'm using n and m for dark and bright so that we don't confuse. What is the position of mth dark fringe? If you remember the formula for mth dark fringe, it was 2m minus 1 into lambda d by 2d. Do you remember this? Yes or no? No, yes.
Yes, sir.
Now you can also write it as 2m minus 1 into beta by 2, and it becomes easier for you to remember now. Easier for you to remember both the things, that beta is nothing but lambda capital D by small d. Do we understand this? Yes or no? No, yes.
Yes, sir.
I hope everyone is writing. I will tell you one more thing, and then probably I'll give you more time to write. Now, sometimes I have seen question coming where they ask you the distance between one bright and one dark, or one dark and one bright. I have seen question of this nature coming in your NEET exam. You can obviously do it very simply, but if you want to have a formula for this, this is the formula that we can use for nth bright fringe, the distance between nth bright and mth bright. Remember, here I've assumed that n is greater than m. So the distance between them will be n minus, the part difference will be this much. So do not write this one. This might confuse you. This might confuse you. So you do not write this part. You just write it like this. If n is greater than m, then the distance will be n minus m plus half beta. If n is less than m, it will be m minus n minus half beta. Please don't confuse. It is very simple. If you divide this equation by 2, you look at the blue thing. If you divide it by 2, you will get m minus half. So that is why they put the value of m minus half, and they have got this formula, this particular formula. You understand this? Yes or no, everyone? Please
Yes,
raise your
sir.
hands and let me know. Okay, I'll give you 2 minutes to note this down.
Done, sir.
Yes,
Everyone has noted this down, beta?
yes, sir.
Okay, there's one more point that I'm looking at. Okay, I will give it from here only because I have seen question of this type come in one of your exams. So I'll give this as a note to you and you will see where we are going to use this note. So this is the note that I am giving to you. Remember, this question has come in one of the previous exams a number of times. So note this down. Instead of me writing, I will just give you a note. So what is the note? Now sometimes they ask the question in this way that N1 fringes are formed when you use a light of wavelength lambda 1, and then they ask you if the light is changed from lambda 1 to lambda 2, how many fringes would be formed. So basically you have to find out the value of this N2. Now how do you find out the value of this N2? N into lambda is remaining constant because we have the same space. N into lambda into d by d is fringe width, d by d is constant. So we have the same space. So n lambda will be constant. So you can use this concept. Oops. So you can use this concept. What is happening? So you can use this concept and get the answer. N1 lambda 1 will be equal to N2 lambda 2. Do we understand what I'm saying here? Yes or no?
Yes,
No,
sir.
yes. Okay, I'm giving you 2 minutes to note this down. Once you note it down, please let me know. So, I was talking about conditions for good interference. When do we have good interference? Some people also call it sustained interference. What are the conditions of good interference? Number one condition, the phase difference delta phi between the two sources must always remain constant. The phase difference between the two sources must remain constant. If the phase difference does not remain constant, beta, we will not get sustained interference. We will not get good interference. Do we understand this? Yes or no? No, yes. That means for
Yes, sir.
constant phase difference, we call that source as coherent sources. Yes or no? The sources must be coherent in nature. That is the first requirement for having good interference. All these points we have already discussed. I am just going through them again so that we don't make a mistake anywhere. Frequency and wavelength should be same. If it's not same, then the phase difference will not be remaining constant. It again requires that the forces must be coherent. All these points have actually come as questions in your examination hall. So these are potential questions from your examination hall. Everyone understands this? Yes or no?
Yes, sir.
I hope
Yes, sir.
everyone is noting it down as well. Yes or no?
Yes, sir.
Okay, frequency and wavelength should be actually equal. We have written this thing twice. We are still writing it. The light must be monochromatic. Monochromatic means the light must be monochromatic. That means it
Single.
will be of single wavelength. We all understand this, yes or no? If you have multiple wavelengths, different lights, you will not get good interference. Everyone understands this, yes or no?
Yes,
Yes,
sir.
sir.
Amplitudes of both the waves that are coming should be almost equal. If they are equal, we will have great interference. If they are equal, then the maximum intensity that we get is 4 times the intensity of one. The minimum intensity that we get is actually equal to 0. I hope all of us remember this. Yes or no?
Yes, sir.
Sources must be close to each other. Why we want the sources to be close to each other? Because your beta, which is your fringe width, is inversely proportional to d. If the sources are very far away, your beta will become small. Dark fringe and bright fringe, the width will become very small, and it will be very difficult for you to observe where is bar bright, where is dark. So the sources must be as close to each other as possible. Do we understand this, bacha?
Yes, sir.
I'll give
Yes,
you
sir.
2 minutes to note this down. Please note it down.
Completed, sir.
Done, sir.
Okay, now we will move on and solve some problems based on this. I'll give you 2 minutes first to go through whatever formulae we have done, so that while we are solving questions, you don't have to look at those formulae. So go through all the formulae that we have done. There's only one or two things that are left. Go through these formulas: formula of fringe width, formula of angular fringe width, formula of net dark, net bright, or whatever. We'll give you 2 minutes. Then we will come back and solve some questions. Remember, only 2 or 3 formulas you'll have to remember. And trust me, there is going to be a question that is going to come from this particular topic. 2 minutes. If you have any doubts, in the meantime, you can ask me. 2 minutes I'm giving you. As soon as you are done, the question will bounce on your screen. I've already put the question. I'm just waiting for you to tell me, sir, we are ready for the questions, and then I will put the question. All the formulae, all the short notes, and I will make sure that we are using all the formulae and all the short notes, and you will see why one particular thing was given to you and why it was given. Are we ready for the magic?
Yes, sir.
Then here comes the first question. This question is a pet question in many NEET. It has also come in JEE as well. So this is the first question. In Young's double-slit experiment using sodium light, 92 fringes are seen. If a given color, different color is used, the wavelength is given 5461. How many fringes would be seen? I'll wait for 2 minutes for your answers.
Sir,
Yes, bacha.
99.
99 is the correct answer. Well done. And everyone got this 99.
Yes, sir.
So it was quite simple. You already know the formula. N1 into lambda 1 is equal to N2 into lambda 2. Everything was given for a reason. Your N1 is given as 92. Your lambda 1 is given as 5898. Your lambda 2 is given as 5461. You had to find the value of N2. So how do I get the value of N2, my dear friends? N2 will be equal to N1 lambda 1 divided
By
by. How many of you calculated it? All of you calculated it?
Yes,
See
sir.
better. Here is where you have to become smart. Here is where you have to become smart. You don't need to calculate it. Why you don't need to calculate it? If you use your mind, your brain, you will look at the option and without calculating, you can tell me the answer. See what is happening. Initially, lambda was 5898. Now the lambda is 5461. The value of lambda is decreasing. Yes or no?
Yes, sir.
N into lambda is constant. So the value of n will increase. Yes or no?
Yes,
Yes,
sir.
sir.
Is only one option which has more value than n1. And that option is. See, I did not calculate anything. I still got the answer.
Yes, sir.
Smartness, we call it. Now, if it had more than one value, more than n1, more than 92, it had 95, 99, which will hardly happen. Remember, your NEET exam or your JEE exam is not about calculation always. It's about using your brain correctly. 62 cannot be the answer. N2 cannot decrease. 67 cannot be the answer. 85 cannot be the answer. Only option is 99. You don't have to calculate it. You wasted important time of your paper in calculating things that should not have been calculated. Learn it. Some people ask me, sir, they are always students ask me, sir, please tell us some tricks in the exam, what tricks we should use. These are all tricks. And I keep on telling them, when I was telling you, did not realize there were tricks. So now I say the word trick so that, oh, trick, this is a trick. This is not trick, this is smart work. Use them. Now, how do I know all these things? I've been teaching for around 15, 20, 25 years, so I know what types of questions are going to come and where you can use your brain. Now, you can only use your brain when the options are right in front of you. If the options are not there, but that will not happen to you. Look at the options also. Without, do not jump onto solving the question without looking at the options. Look at the options. Because by looking at the options, we may not have to calculate it. You just have to take it. Save time. Because time is a luxury that we don't have. And time is the factor that is going to decide what? That is going to decide who scores how many marks in the exam. And remember, to get any good college out of 180 is the physics paper, no? 180?
Yes, sir.
Yes.
To get a good college, you must get somewhere around 650 plus. To get around 650 plus, you must get somewhere around 150 to 160 in physics. So 160 in physics, 160 in chemistry, that takes you to 320. Then the next 340 marks will come from your bio, and that is how you get to 650 plus. A decent score, a very good score, I should say, that will land you up in a very good college of your choice. Here comes the next one. Save time, my dear friends. Time is a luxury that we don't have. No one has. No one can beat time. In Young's Superposition experiment, an interface pattern is observed on a screen by a light of wavelength something coming from coherent sources S1 and S2. At a certain point, P on the screen, third dark fringe is formed. What is the path difference? I'll give you 2 minutes. Shall I wait more? Or shall I give you the answer? Okay, I'll give you 2 more minutes, it seems. Everyone is busy in answering. Yes, bacha. So long. Remember, any question in a NEET exam, if it takes more than 1 minute, you are probably not doing it, because you have to do 45 questions if I am not wrong. Yes or no? In a space of 60 minutes. So hardly you will get 1 minute per question. So if you are taking more than 1 minute here in the examination, here in the class, that means probably you are not doing it correctly. Yes. Yes, bacha. Huh? No answer?
B.
B. I have got an answer after so much time, and that is B. Let me see if it is B. The answer that I have is B. 1.5 microns. That is correct. Now the
Yes, sir.
question is, how did you get it? Remember, beta, we talk about tricks. Be smart. What is given in the question is the third dark fringe is formed part difference. Remember, they have asked you only the part difference. How do you get the part difference for the third fringe?
-1/2.
Well done. That is the first. The mth fringe, the formula is 2m minus 1 into lambda by 2. Yes or no?
Yes, sir.
Here m happens to be 3. So the position of the third dark fringe will be 2 into 3 minus 1 into lambda, 6000
By 2.
by 2. Now it is written as 6000 Armstrong unit. So you should basically multiply it by 10 raised to the power minus 7. But again, look at ways of saving your time. That is what I mean by doing work smartly. Now, if I write 1 alphabet, 2 alphabet, 3 alphabet, 4 alphabet, or 4 numbers, I take 1 second each or 0.5 second each. So if I write 4 zeros even, I will take 4 seconds extra. Now look at the options. All the options, they do not have any unit. They are in the same unit. So basically, it's not like one option is given in centimeter, other one is given in meters, other one is given in mm, that you must worry about the zero. You should not worry about the zeros. You don't even have to write 6000. You can simply write it as 6. You don't have to write that Armstrong unit also, because everything that you see here is in the same unit. Are you getting my point? What I
Yes,
have saved here is, I have saved 3 zeros and I have saved 10 raised to the power minus 7. So I have saved 6 or 7 alphabets or numbers. I have saved 6 or 7 seconds. That 6 or 7 seconds, if you save in every question, 45 into 6, you will get a lot of time that you can do at least 1 or 2 questions more. Are you getting my point? Save your time in. You just need to calculate this. This is very simple now. And you will get, I think, 1.5 from here. Yes or no?
yes, sir.
You're done. You might get 1.5, you might get 15. That doesn't matter, because you know one is 0.75, one is 1.5, one is 3, and one is 4.5. I think you will get 15 here. So 15 is 1.5. Do you understand this? Because I'm not taking that zeros in my consideration. Zeros are out of my consideration. We got this?
Yes, sir.
Good. Smart hard work. You can call it trick. You can call it smart hard work. Doesn't matter, as long as you are doing it quickly. Remember, your exam is going to happen in 4 or 5 months time. After your board exam, as soon as your board exam is over, July, probably you will have your exam. Become quick now. This is the next one. Let's see who can give me the answer. I know that you can give me the answer. Can you give it fast enough? In the Young's double slit experiment, the slit width is 1 mm and the screen is 1 meter from the slit. Remember different units. For a monochromatic light of wavelength 500 nanometers, what is the distance of third minima from the central maximum? They are not asking the path difference beta, they are asking you the distance of the third minima from the central minima. You have 2 minutes to show me your talents. Else I'll show mine. Mine is not good enough.
Sir, 1.25.
Yeah, so quick. Wow, that is exceptional. 1.25 and that is the correct answer. Well done. Who got this answer? So quick. Oh, I can't see you. I think I have got all. No, I can see you. Yes. So it is very simple. See, I do the question doing all the steps, but you don't have to do all these steps. I am doing it so that you understand why it is done. Now I have to find the distance of the third minima. I used for formula of YM. I must go back to this. Here I had used the formula of YM. It was not YM. We have used YM for the distance of the minima. It was the part difference. So just I must change the symbol here. I hope you understand. I've changed the symbol here. This is the symbol for part difference. Okay, part difference. Sorry, because Y we are using for the distance from the central fringe. Okay, so I'm sorry. I used the wrong symbol. I'm very peculiar about symbols. Now we have to find the distance of the third minima from the central maxima. So the formula is, remember, you don't have to write this formula in the examination hall. I'm just writing it so that you understand. I put the value of m as 3. Third minima is 2 into 3 is 6. 6 minus 5. 5 into lambda. Wavelength is 500 into 10 raised to the power minus 9 nanometer multiplied by distance d is 1 meter divided by 1 millimeter, 1 into 10 raised to the power minus 3. I wasted a lot of time. Do you see I wasted a lot of time?
Yes,
I've
sir.
just wasted a lot of time in writing all this wrong color. All these stupid things. I should not have written all these stupid things. Yes or no?
Yes, sir.
I should have only written things that matter. 5 into 5 divided by 2. That is the only thing that matters. Do we understand this?
Yes,
Why I
sir.
could do this? Because beta, all of them are in the same unit. So there is no problem of all these zeros. Zeros don't matter here. Only the numbers matter. 5 into 5 is 25. 25 by 2, 12.5. Look at the option which looks like 12.5. The decimal can be here or there. So the option that looks like 12.5 is 1.25. That is your answer. You understand this? Do not
sir.
look for other things. Keep your focus straight. And this way you can save a lot of time and you can make the calculation pretty damn simple. The last question for today, let's see how quickly you can give me the answer for this one. The two slits of 1 mm at a distance of 1 mm are illuminated by a light of wavelength 6.5 into 10 to the power minus 7 meters. The interference fringes are observed on a screen placed at a distance of 1 meter. The distance between the third dark fringe and the fifth bright fringe is. And you have your options right in front of your eyes. And you have 2 minutes to do this. And stay happy. Yes, my dear friends. Any answers that you have that you can give me? Or shall I do the needful? Eh?
Sir, option C.
Option
C.
C, 3.25. The answer that I have is option B, 1.63. That means you have done the double of it. How do I get this? So you can use the formula straight away, or you don't want to use the formula, you can remember how the formula was made. So the distance between the two fringes, let me call it as delta x. The distance between the two fringes, n is greater than m. The formula was n minus m plus half. Do you remember that formula? Into beta. N is 5. 5 minus 3 plus half. To find the value of beta, you multiply it by 6.5 into 10 raised to the power minus 7. That is your lambda into 1 divided by your distance was 1 mm. 1 into 10 raised to the power minus 3. As you can see, I wasted a lot of time and energy in writing things that were not useful. What were not useful? This was not required. This was not required because I'm just wasting time. So this is not required at all. So what I need to do was 5 minus 3 is 2. 2 plus half is 5 by 2. Yes or no?
Yes, sir.
So 6.5 into 5 divided by 2. That is your answer. .5 into 5 divided by 2. Remember, here also you could have used a bit of smart work. You look at the options. Options are very different from each other. Yes or no? Now, instead of multiplying 6.5, it will not make much difference. You can simply multiply 6 by 5. How much is 6 by 5? 30. 30 divided by 2 is 15. But your answer was 6.5. So it must be more than 15. Look at the option which is more than 15. Nearby 15 and more than 15. Which is the option which is nearby 15 and more than 15?
Option B, sir.
Option B, sir. You have saved again a time. 6.5 multiplied by 5 will again take some time of yours, but 6 multiplied by 5 may not take that much of time. 30 divided by 2, 15. Look at the option which is nearer to 15. Do we get this? Do we understand how we use our time?
Yes, sir.
Small things make a big difference in your eventual answer. But please, when you are using these things, please be careful. If the units are different, then you must follow all the zeros. But I have not seen question where the units are different. Hardly. And if the options are very close to each other, then you have to do exact calculation. If the options are very away from each other, very apart from each other, you can do approximate calculation and you will get your correct answer. Do we get this? Yes or no?
Yes,
Yes,
sir.
sir.
Remember these things. Keep this thing in your mind. When question comes, you will understand how valuable this information is. On that note, I am winding off today's class. In today's class, we have done almost everything in young double slit experiment. Now I'll give you some important pointers and points and 2 or 3 more questions, and we are done with the YDSE. Probably we shall then move on to the next topic, which is diffraction. Anyone having any doubt, please come up to me. Else, this is a wrap from my end. I hope everyone understood what we had to do. Try more questions. I've already sent you the sheet. I hope you got the sheet. Yes or no? Yes, you got the sheet. Try questions from those sheets. If you can even do 50% of the questions, you can do anything that comes in the examination. All take care. God bless you. Bye bye.